Hello guys and welcome to another session. So in this session today we are doing the most recent past paper related to MCQs available to us right now, which is the March 24 paper from the IGCSE. So because IGCSE has two variants of the MCQ paper, it's core and extended. So core being the easier one, we are doing extended, which is the only way you can get a grade above a C in IGCSE. So this is the most recent paper that we have available right now. If you are an O-level or an IGCSE student, I strongly suggest that you try this out just so that you know how solid your prep really is and how ready really you are for the exams. So let's get right into it. So question number 1, a student has a measuring cylinder containing water and also has a balance. Which of these could she use to find the volume of a small metal sphere? So because it's a sphere, I can really use the formula for the volume of a sphere to find out the volume. But she has no other apparatus. So it's not possible for her to take the reading of a sphere, which is going to allow her to find the volume. Because the formula is 4 by 3 pi r cube. You're not supposed to know this, but anyway, you would need the radius to find the volume. But you don't have anything to measure the radius, so you can't do that. So to find the volume, you can now use this, that since you have a measuring cylinder containing water, you can note its initial volume. And then after submerging the sphere inside the water, you can see the final volume. And the difference of those is going to be the sphere's volume. So either the measuring cylinder or the balance, again, the measuring cylinder, the balance will give you the mass. You just need the measuring cylinder containing the water. Again, the balance gives you the mass, and the measuring cylinder is what you need. On to question number 2. The diagram shows a solid object on a flat surface with two forces acting on the object. What is the resultant force? So we see here 4 to the right, 3 to the left. 4 is more than 3, so the resultant would be to the right, and it's 4 minus 3, which is 1 to the right. So that's pretty easy. A ball is falling towards the ground. Which transfer between energy stores is taking place? So if it's falling, then I know that because of this formula, because the height is decreasing, then the gravitational potential energy is decreasing. But by the conservation of energy, this decrease in the potential energy stored must be transmitted into to an increase in some other energy stored, which we know here is going to be the kinetic energy. So it's GPE into kinetic energy, which is C. No elastic energy associated here. Elastic energy is energy stored in stretched objects. 4, which row contains one scalar, one vector? Energy, velocity. This is correct. Energy is a scalar, velocity is a vector. Mass, time, both scalars. Momentum, weight, both vectors. Distance, temperature, both scalars again. Question number 5. The table gives data about 4 liquids W, X, Y, Z. So you have, for each liquid, you have the mass given and the volume given. None of the liquid mixes with any of the other liquids. All of the liquids are put in the same container and settled to form 4 separate layers. Which statement is correct? And if you look at the statements, just really quickly, so you know that it has to do with the level each liquid finds. So we know that how each liquid will settle depends on their densities. So given the mass and volumes, I can very easily find out their densities. I'm just going to go ahead and use this formula, mass over volume. So 10 over 10 is going to be 1, 20 over 15 is going to be 1.33, 30 over 50 is going to be 0.6, and 40 over 50 is going to be 0.8. So A says W forms the layer below X. So if it's below X, this means W must be denser than X, which is not true. So this is wrong. X forms a top layer. So if X is at the top, this must be the least dense, which is also not true. Y forms the bottom layer. No, that's not true either, because for it to be at the bottom, it must be the densest, which is not the case here. And by default, D must be correct, which is Z forms the layer below Y. So for Z to be below Y, it must be more dense, which it is. So the answer to this one is D. All right, let's go back. So question number 6. Question number 6, a weightless beam is balanced on a pivot as shown. So the beam does not have any weight of its own. Forces P, Q, and R act on the beam. Which equation is correct? So we see some forces labeled here along with their distances. So if I just see here, I see 3 forces. Now, in the case of 2 forces, I can very easily say that if there are 2 forces and something is balanced or in equilibrium, then I know one must be producing a clockwise moment, the other one must be producing an anti-clockwise moment. I don't even really need to see in that case. But with 3 forces, it could be a case where 2 are clockwise, 1 is anti-clockwise. 2 could be anti-clockwise and 1 could be clockwise, so I need to see here. So if I look at Q, this produces a clockwise moment. Right, so Q is producing a clockwise moment. So this is clockwise. If I look at P, P is obviously anti-clockwise. And if I look at R, this is also clockwise. So basically writing out the principle of moments, I would say sum of clockwise moments equals sum of anti-clockwise moments. So the anti-clockwise moment here is because of P. So P and its distance from the pivot is D. So P, D. And then for the sum of the clockwise moments, it's going to be this force times its distance from the pivot, which is going to be QB. And then for the last one, if we look at this, so it's the clockwise moment again. So R times its distance from the pivot, which is RA. Now I just need to see which equation, which choice fits in with this. So it's definitely not this, definitely not this, definitely not this. It's this. This is just rearranging this equation so that QB is on the left and so that it subtracts. Right? Question number 7. An object is moving at positive 3 meters per second. A force acts on the object. After a time, the object is moving at -4. Mass of the object is given. What is the change in momentum of the body? So that's really delta P, which you might also know as the impulse, which is final minus initial momentum. Final momentum means mass times final velocity minus mass times initial velocity. So M is 5, final velocity is -4 minus 5 times +3. So 5 times -4 is -20, -15, which makes it -35. So the answer in that case is A. All right, let's go on. The diagram shows a column of liquid. The pressure due to the liquid at the bottom of the liquid is 6,000 Newton per meter squared. What is the density of the liquid? So we use this formula for the liquid pressure, rho GH. So pressure here is 6,000. Rho is what we need to find. G is 9.8 and H is 50 centimeters. So to have everything in SI units, you would need to convert this to meters, which would be 0.5 meters. And from here, we just make rho the subject. So 6,000 over 9.8 times 0.5. And we can solve this to get our answer here. So we just solve this then. 6,000 over 9.8 times 0.5, which is 1224. So to 2SF, it's 1200 kg per meter cube. This statement correctly describes a change of state. A gas condenses to form a liquid. This is true. A liquid melts to form a solid. This is wrong. A solid melts to form a liquid. A solid condenses to form a liquid. Wrong. A solid melts into a liquid. And a solid boils to a gas. Again, wrong. A solid sublimes to a gas. And the gas to solid journey is also called sublimation. All right, question number 10. The diagram shows a pan used for cooking food. Which row is correct for the materials used to make the base of the pan and the handle of the pan? I know that for the base of the pan, for the heat to be conducted, it must be a good conductor. So good and good. And for the person handling the pan, so that he or she does not burn themselves, it should be a poor conductor, or what I could also call a good insulator. So that's B. Easy. 11. Solar heating panels consists of pipe carrying water that absorb radiation from the sun. Which texture and color is the surface of the pipe so that the temperature of the water rises at the quickest rate? So if it's absorbing, it needs to be a good absorber so that it happens the quickest. So it must be dull black. That's just the rule. So that's A. Next, when pollen grains in water are viewed through a microscope, they are seen to be in continuous, rapid, random motion. What causes a pollen grain to move in this way? So this is bombardment by the water molecules, right? That's what causes the movement like this. And again, this is some stuff which is only IGCSE. It's not in the O-level syllabus, and it's bombardment by the water molecules. So this is going to be C, because it's not just moving in one line, and it would move in one line if it was just being bombarded by a single molecule, because that exerts a force which causes it to move in a straight line. But it's very haphazard movement, which shows it's being continuously bombarded by all sides from the different molecules. 13. A circular flat bottom dish contains 100 cm cube of water. Students are asked how to increase the rate at which the water evaporates. You know, there are three factors for which really affect the rate of evaporation, which is the temperature, the surface area, and the movement of wind, or what you may also call drought, over the liquid surface. So pouring the water out into a large flat bottom dish of larger diameter exposes more area. So 1 is definitely correct. So any option which does not contain 1 is wrong. Cool the dish in water. This is wrong. This is going to decrease the rate of evaporation. So 2 is wrong. So not this, not this. I don't even need to look at this. It must be C. And if I see what 3 actually says, this is true, that if you have some drought over the surface, so this will increase the rate of evaporation. 14. Matter consists of very small particles in a continual state of motion, which row describes the behavior of particles in a liquid. So forces between particles is not going to be weak. They are still relatively strong, so it's definitely strong. And motion of particles, they don't just vibrate, they move. All right, so it says vibrate, but in change positions. So yeah, that's the idea here. They don't move randomly at high speed. This would make it gases, but they vibrate. And what we say is that the layers of particles can also slide over one another, which basically explains why liquids flow. So the answer in this case is B. Let's go on to the next one. All right, so this is a question where you don't even really need to look at the options, to be honest. The diagram shows the equipment used in an experiment on the heating of aluminium. The table gives the results for the experiment. Specific heat capacity of aluminium is given. What is the max possible temperature rise in the block? So when we're talking about the max possible rise, so for the max possible temperature rise, why it says max is to assume that there is no loss at all from this block. That's what gives us the max rise, but in reality, there would be some loss. So the actual rise would be less. That's why it uses the word max. So if I try to do this here, obviously I would need this equation, which involves the specific heat capacity. But if I see here, I don't have the energy really given. Instead, I have voltage, current, and time, using which I can find out the energy delivered, because electrical power is VI. And then if I just multiply power by time, this gives me energy. So I just do VIT equals to MC delta T. So delta T here, if I want to find that out, it's going to be VI, so 12, 5. Time is in seconds, so that's all good, over MC. M is in kg, this is also in per kg, so that's also fine. So 0.8 times 900. Let's find out what delta T is. So 12 times 5 times 300 over 0.8 times 900, which is 25. This is just the rise in temperature. Are we given some? Also, we were asked for the rise. Thought it was the final temperature. So yeah, that's just C. All right, let's go on to 16 now. The diagram shows a wave. So if I look at the axis, it's a displacement and its position. So this is the displacement distance graph. It's not a displacement time graph. Which dimensions describe the properties of the wave? So if I see here, P is not the amplitude, it's twice the amplitude. R is the amplitude, right? Because by symmetry, what this distance is also this distance. So R is the amplitude, so it's either C or D. And then if you look here, so basically from two of the same points but on different waves, this is one wavelength, this is half a wavelength. So Q is the wavelength. So it's C. 17, which row describes some characteristics of an image formed in a plane mirror? So in a plane mirror, we know that the image is virtual, it's not real, and it's the same size as the object. Easy. Range of audible frequencies for elephants is given, and the range of frequencies for horses is also given. This statement about the range of audible frequencies for a healthy human ear is correct. So A says the human ear. So first off, actually, let's wait a while and write down the audible frequency range for humans, which is this. So this statement about the range of audible frequencies for a healthy human ear is correct. A says the human ear can hear all sounds heard by both elephants and horses. So all sounds heard by elephants and horses, the human can also hear. Is this true? This is obviously not true because humans can only hear as low as 20, but elephants can hear as low as 10. Similarly, horses can hear as high as 33,000, but humans can only hear as high as 20,000. This is wrong, right? The human can hear all sounds heard by elephants, but not all those heard by horses. We just saw that the humans cannot hear all sounds which elephants can hear. Human here can hear all sounds heard by horses, but not all heard by elephants. This is also wrong. By default, D must be correct, which is that the human ear cannot hear all sounds heard by elephants, nor those heard by horses, right? So there are some frequencies which are out of the human audibility range. So this one is D. Let's go on to 19 now. An object is placed in front of a plane mirror. The ray diagram shows the reflection of one ray of light from the object by the mirror. Where does the mirror form an image of the object? So we know this is a property that how far in front of the mirror the object is, the image is formed exactly that distance behind. So it's obviously A, right? So that's how we do this. 20, light refracts as it enters glass from air is shown, which expression is equal to the refractive index of glass. So I can see here that for refractive index, I need angles with the normal. One of these here is not with the normal. So if this is 90, that also means this is 90. So if this is 90, so this angle that we need with the normal is 90 minus theta 1. And the formula, as how I told you, it's sine of the angle in air over the sine of the angle in glass, right? So this is sine 90 minus theta 1. That's the angle in air. over sine theta 2. So that's very easy. It's C. All right, let's go on to another one. This is also a good question, not really difficult, but it definitely does use a formula that most students tend to overlook. Light traveling at a speed of 3 into 10 to the 8 meters per second strikes the surface of a glass block and undergoes refraction. The diagram shows a ray of light before and after. What is the speed of light in the glass? So in this case, what we use is that we are all aware of this idea that n is sine I over sine r, which is the angle of incidence, the angle in air divided by the angle in the other medium. But people do tend to forget this formula that after all, the refractive index is really the ratio of speed in air to the ratio of speed in that medium. It's the change in speed of light which causes the refraction, right? That's what causes the bending and not the other way around, right? So always do remember this. So sine I is sine 55. Again, I'm taking the angle in air despite what I've written, and sine 33. And just to double check, both of these angles are with the normal, so nothing I need to do here. This is 3.0 into 10 to the 8, and this is V. So on my calculator, I do sine 55 over sine 33 first, and then I do 3 into 10 to the 8 divided by, so 3 into 10 to the 8 divided by this value, which is almost 2 into 10 to the 8, correct, to 2SF, right? So that's this. Which row about converging diverging lenses are correct? Converging lenses always produce inverted images. This is wrong. In what I call case 6, where an object is placed between O and F, it can produce a virtual upright image which is on the same side of the lens as the object. Converging lens can be used as magnifying glasses. True. Diverging lenses do not have a principal focus. False. Diverging lenses do have a principal focus. Converging lenses can be used to correct short-sightedness. All right. So I obviously remember this, but just to show you guys what short-sightedness really is if this is the eye, and if this is the ray of light entering. So short-sightedness means that it converges before, right? This is short-sightedness. We say it converges a short distance from the lens in the eye. So if you use a converging lens, this means it's going to make it meet even before, which is not what you want. For a sharp focused image on the eye, we would want it to meet at the retina. This is not what we want. It's already meeting before. Why would I want to bend it even more, right? So that's why C is wrong, and by default, D is correct. So diverging lenses can be used to correct short-sightedness because these would spread out the rays more so that they meet at the retina, and converging lenses can be used to produce both real and virtual images. A charged rod is placed on a balance and another rod Y is brought close to it as shown. So if I see here, initially it was showing some mass 45.3 and then it's showing 45.7. This means it's pushed down more. So it's pushed down more, so it must be repelled by this charge one. So whatever the charges are, they must have the same charges. So it's definitely negative, negative. Nowhere else do I see a case where the charges are the same. Right? That's this one. What is the unit of potential difference? Pretty easy. That's the volt. The diagram shows a transformer, and then you have a diagram related to the transformer. What is the output voltage? So you have the number of turns, so finding the output voltage is not very difficult, really. You can use the turns ratio equation, which says that the number of turns on the primary over the number of turns on the secondary would equal the voltage of the primary over the voltage on the secondary. So primary turns are 550, secondary turns are 115, VP is 22,000, as I can very obviously see here, because there are less turns on the secondary coil, the voltage must be less than the primary voltage, right? This is the step down transformer. So if I do get an answer more than 22,000, this means I've made a mistake with the calculations. So to find Vs, 22,000 times 115 divided by 550, just 4,600. So that's C. All right. 26, the diagram shows two arrangements of a pair of identical bar magnets. So you have diagram 1, you have diagram 2, 3 points P, Q, and R are as shown. At which point is the magnetic field due to the magnet's weakest, and at which point is it the strongest? So first off, I can see that the magnetic field at P would definitely be 0, right? Why would it be 0 is because this is a case of like poles. And what would happen here is that these field lines, if I were to draw these, so it's out from the north, so they would be canceling out at this position, right? So the weakest field is definitely at P. It's almost no field at all. And the strongest field, where would it be? Would it be at Q or would it be at R? So the idea here is that because you'll have field lines like this from north to south, and right between the poles, you would have a field which consists of parallel lines. So because you would have a field which consists of parallel lines, you might be tempted to say that it's strongest at Q. But the reason is that because it's so close to this magnet, the magnetic field strength would be strongest at R. These are still some distance away from both of these magnets, but R is literally on the magnet. So it would have the closest field line. So the field would be strongest at R. All right, that's the answer to this one. Let's see. 27B, a nichrome wire has length 1 meters, diameter 1 mm. A second nichrome wire has a length of 2 meters and diameter 2 mm. So double the length, double the diameter. Which statement correctly compares the resistance of Q with that of P? We know that resistance is directly proportional to length, inversely proportional to area. But because I can say that area is basically pi r square, I can also write it in terms of the diameter, where I would write instead of r, I would write d by 2, and squaring that would lead to this equation. So the idea that follows from here is that area is proportional to the diameter squared. So because I am provided diameters, I can write this equation in this way, that I can say, so what I can say is that resistance is proportional to length and inversely proportional to the square of the diameter. So because of the resistance, because of the length, because it's direct proportion, so if length doubles, resistance also doubles. But because it's inversely proportional to the square, this means that if the diameter doubles, the resistance would decrease by a factor of 4. So it would become 1/4 of what it actually is. If you don't believe me, you can also try this out with some dummy values. Let's say you say that because this is a constant of proportionality, you also write out a constant here, right? So it's R equals to K times 1/1. And let's say R is also 1. Let's keep it very easy. Actually, let me just do this to explain you guys. Let's do it here. So let's say I take R as 1, L as 1, K as 1. So 1 equals to K times 1/1. And let's say I don't even care about the units, right? So it turns out to be 1. All right. So K turns out to be 1 from here. And then if I use the same equation where I say that using direct proportion, R equals to K times L over D square. right? So I basically use this equation. So because the square of 1 would also be 1. And now if I use this, K as 1, L as 1, and diameter as the square of 2, so this would be 1/4. And now I see, at least I hope that you guys can see what I've done here, right? So previously the resistance was all right, apologies. This is not 1 anymore because the length is now 2, so it's 2. So 2 over 2 square would then be half, which is the exact same thing that we were seeing from what we did with the ratios here, that the resistance is just going to half. It's going to double because of the length, and it's going to decrease by a factor of 1/4 because of the increase in diameter, and that's going to be half. So it's 1/2 of the resistance. So that's B. 28, a student has two resistors. One resistor has a resistance of 2, the other has a resistance of 40 kilo ohms. Which statement is correct? When connected in parallel, the combined resistance is 1.9 ohms. Again, I don't really even need to pick up a calculator for this. The idea is this, and why we do not need to pick up a calculator is because I know this very important rule, which is that when resistors are connected in parallel, the resistance is smaller than the smallest resistor, right? So 1.9 is definitely correct. But because I see in the next line, it says combined resistance is 2, I'm just holding off here because it could be possible that it's like 1.99, which is technically smaller than 2. But I just want to make sure that that is not rounded up here as 2. So we'll do that calculation in a while. When in series, the resistance cannot be smaller than either resistance. In fact, it's going to be larger than the largest resistance. So it's 40 kilo ohms and 2 ohms, so it must be greater than 40 kilo ohms. And for the same reason, this is also wrong because this is not just ohms, it's kilo ohms. So now I'll go ahead and do this, which is 2, so 1 over 2 plus 1 over 40 kilo ohms. This is 1 over R, so this I'm going to inverse. That's how I write this, just to show that this is 1 over this thing. So 2 inverse plus 40,000 inverse, inversed, which is 1.999 C. So it's B, right? So this is why I was holding off. And honestly, I did not even know what it's going to be, but that's just a precaution that I took. 29, in which circuit to do both lamps light? So for example, in this case, we start with A. So this is positive, negative, current flows like this. So in this case, neither of these circuits would light up. So definitely not A. In this one, again, current would go like this from positive to negative. It's not going to happen here either. C, we can see that in this case, this one would light up because current would go here. And also this one would light up. This is definitely correct. If I see this one, so positive to negative, this one would light up, but this one would not. So it's C. An isotope of strontium has nuclide notation SR8438. How many protons and neutrons are there in a nucleus? So protons are definitely 38, and neutrons would be 84 minus 38, which would be a number like 46. A student is investigating the count rate of a radioactive substance. How must he adjust his reading for the background count? It's very easy. You just subtract the background count. So that's this. Repeating readings does not eliminate the background count. Make sure you do understand this. What occurs during nuclear fusion? So you have two lighter nuclei joining together and emitting energy, which is A. All right. Let's go on to another one, which is 33. So 33 says a beta particle enters a uniform magnetic field directed into the page and deflects downwards as shown. This direction of electric field would also deflect an electron downwards. This electron right now we see is deflecting downwards. And why do I say an electron? Is because it's really a beta particle, right? It says which direction of electric field would also deflect an electron upwards. If you remember what an electric field shows, it shows the direction of force on a positive charge, right? It's according to a positive charge, which is not what we have here. What we have here is a negative charge. So if I want my negative charge to be deflected downwards, this means my positive charge would be deflected upwards, and that's how the field lines would be. So they would be upwards lines like this. So what I'm going for in this case is a field line that goes up, right? This is not going to be into or out of the page. It's going to be just upwards. All right, let's go on to the next one. Radioactive isotope radon is an alpha emitter. During this decay, an isotope of polonium is produced. How many neutrons does a nucleus of this isotope contain? So this is pretty easy. When this guy is going to decay by alpha emission, this means it's going to give out alpha 4, 2. So the nucleon number is going to decrease by 4, proton number is going to decrease by 2. So this would make this polonium 84, and 222 minus 4 is going to be 218. It's asking for neutrons, so it's going to be 218 minus 84. Right, so 218 minus 84, which is 134. Next, this statement gives 2 safety precautions to take when a person is working with ionizing radiation. Decrease exposure time, obviously you don't want to increase it, and increase distance between person and source, that's B. Which list correctly shows the planets in decreasing order of distance from the sun? So my very educated mother just served us nachos, or my very easy method just speeds up naming, that sort of a thing. So it's decreasing order of distance, right? So it's decreasing order. So this is the closest. So here we're really going the opposite way around. So Neptune, Uranus, Saturn, and Jupiter, this is absolutely correct. That is exactly what we're going for. If you try out any other combination, it's just not going to work here. So it was decreasing order. 37, the sun radiates most of its energy in the 3 regions, which is infrared, visible, and UV, right? So UV is this one. Most of it is infrared. The next major contributor is visible light, and the least is UV. The diagram shows a comet moving in an elliptical orbit around the sun. At which position is the comet moving with the greatest speed? Greatest speed means greatest kinetic energy, which by the conservation of energy means the least potential energy. And there's really no height here. So potential energy in this case is because of distance from the sun, right? So least distance from the sun is at A when it's closest to the sun, so it moves the fastest. Nuclear reactions in the sun release large quantities of energy. The statement about this process is correct. So releasing large quantities of energy, it's because of fusion from hydrogen to produce helium. Question number 40, the table gives data about 4 planets in our solar system. What are planets X and Y? All right, so Uranus, again, if I just copy the order from here, just feeling lazy, don't want to write this out again. So we know that as far apart as we go from the sun, so this is basically increasing distance from the sun. This is the closest, this is the furthest. The further planets are colder because they receive less of the sun's radiation, right? So this is Earth right here, and this is Uranus. So planet X is Planet X is slightly colder, and then this is colder still, and this is the coldest, right? So this should be the Earth. It's the closest to the sun. Then this is the next closest. This is further away still, and this is the furthest away. So after Earth and between Uranus, so I'm looking for either X as Mercury, and sorry, X as Mars and J as Jupiter, or Jupiter Saturn. So yeah, Mercury Jupiter, Mercury Saturn, or it would also be Mercury Saturn, Mercury Jupiter, Jupiter Saturn, or Mercury Saturn for that matter. Either this and this, or this and this, or this and this, right? More or less. So it has to be, if I look at the options, it's definitely not Mars, which is what I myself got messed up with. Mars is the one which is closest, right? No, what am I saying? Sorry, it's all right. Mercury is the one which is closest, right? So it's definitely not Mercury. So it's definitely not Mercury. That's what I meant to say. It's either of these. So Mars, Saturn, or Mars, Neptune. So it's definitely Mars, Saturn, right? Mars, Saturn. So yeah, do make sure that you remember that the one closest is Mercury, because you have two MCQs, right? So Mercury, Venus, Earth, Mars. Mercury, Venus, Earth, Mars. All right. So that's this entire paper then. So I hope this helped, because there is no examiner report as such to help you out as well at this time regarding the solution. So hope this helps, guys. Best of luck for your exams, and do like this video. Please also subscribe to my channel, because I'll be posting more useful videos like these. If you guys have any suggestions about ideas of videos of your own, please do let me know, and I'll try my best to make that happen. So thanks for your time, guys, and see you until next. Bye.